Ladies and gentlemen, we've all heard about keto. We've all tried fasting. And yes, they work. But today, I'm going to share with you something better. You see, most people think weight loss, longevity, and energy all come down to cutting carbs or skipping meals. But there's one trick, one simple, powerful protein trick that can transform your metabolism, your hunger, and even your aging process without starving yourself or counting a single calorie. Protein timing outweighs calorie counting because the human body is not simply a calculator of numbers. It is a complex, dynamic system that responds differently depending on when, how, and in what context nutrients are consumed. Most people have been conditioned to believe that as long as you stay within your calorie limits, the timing and composition of those calories don't matter. This belief is outdated. The human metabolism is governed by hormonal rhythms, enzyme activity, and circadian cycles that fluctuate throughout the day, and protein plays a central role in regulating these processes. When we consume protein at the right times, especially in the morning or after periods of fasting, it triggers a cascade of metabolic reactions that can make the body more efficient at using energy, preserving muscle mass, and burning fat. When you eat protein early in the day, it stimulates muscle protein synthesis, the process through which your body builds and repairs lean tissue. This activation sets the tone for your metabolic rate for the rest of the day. The amino acids released from dietary proteins serve as both building blocks and signaling molecules. They tell your cells that nutrients are available, which in turn influences insulin sensitivity and blood sugar control. A breakfast rich in protein can lower cravings and reduce snacking later in the day, not merely because it makes you feel full, but because it stabilizes the hormonal environment that governs appetite. Ghrelin, the hunger hormone, drops significantly after a protein-rich meal, while peptide Y and GLP-1, the hormones responsible for satiety, increase. This hormonal balance can make you naturally eat less without conscious effort or calorie restriction. In contrast, when most of your calories come from carbohydrates or fats, especially early in the day, the body's insulin response becomes dominant, leading to energy spikes and crashes that promote overeating later. This is why two people can eat the same number of calories, but one will lose fat and the other will not, depending on when and how protein is distributed throughout the day. Protein consumption sets the metabolic stage, not just for energy balance, but for cellular repair, mitochondrial efficiency, and even brain function. Protein timing is also crucial for preserving lean mass during weight loss. When the body experiences an energy deficit, it has two main options for fuel: stored fat or lean tissue. Adequate and well-timed protein intake directs the body toward fat oxidation rather than muscle breakdown. Consuming protein strategically, such as within an hour of waking, after exercise, or before long fasting periods, keeps muscle protein synthesis active while minimizing muscle degradation. Over time, this leads to a more favorable body composition, even if the total calorie intake remains the same. Calorie counting, on the other hand, ignores the hormonal and enzymatic context in which those calories are processed. For example, 100 calories of protein are metabolically different from 100 calories of sugar. The thermic effect of protein means that nearly 20 to 30% of its calories are used just for digestion and metabolism, whereas carbohydrates and fats require far less energy to process. This alone makes calorie counting misleading, because two diets with identical calorie totals can produce vastly different metabolic outcomes depending on their protein timing and composition. Furthermore, protein has a profound effect on insulin and glucagon balance. When eaten at the right times, protein can blunt post-meal insulin spikes, helping keep blood glucose stable. It also stimulates glucagon, a hormone that signals the release of stored energy from fat cells. This interplay promotes a steady flow of energy, reduces fatigue, and enhances mental clarity. When meals are poorly timed and dominated by carbohydrates, insulin dominates, leading to fat storage and a continuous cycle of hunger. Protein timing also interacts with the body's circadian rhythm. Research has shown that the digestive system, liver enzymes, and hormone receptors all operate on a roughly 24-hour cycle. Consuming protein-rich meals earlier in the day aligns with the body's natural metabolic rhythm when it is primed to digest, absorb, and utilize nutrients efficiently. Late-night eating, especially when low in protein, disrupts this rhythm, impairing sleep quality and slowing metabolic rate the next morning. The emphasis on timing does not mean that total protein intake is unimportant. It means that optimal health requires both adequate quantity and strategic distribution. Instead of cramming all your protein into one large dinner, spreading it evenly across 2 or 3 meals can maintain muscle protein synthesis throughout the day. Each dose of protein acts as a signal that keeps your metabolism active. Skipping protein for long stretches, as often happens during prolonged fasting, can slow this process down, especially in older adults who naturally experience anabolic resistance, the reduced ability to build muscle in response to food. When you understand the importance of timing, you begin to view nutrition less as a numbers game and more as a rhythm to be synchronized with your body's biology. Calories measure energy, but they do not measure hormonal impact, satiety, or muscle preservation. Protein consumed at the right times dictates how that energy is used, whether it is stored as fat, burned for fuel, or invested in building lean tissue. It is this precise coordination of timing and biology that makes protein timing more powerful than calorie counting in achieving lasting metabolic health. Prioritize protein before carbs or fat because the order in which macronutrients are consumed has a significant influence on metabolic response, hormonal signaling, and overall energy balance. When protein is eaten first in a meal, it slows gastric emptying, reduces the glucose spike that follows carbohydrate intake, and helps control appetite. This seemingly small shift in eating sequence has profound physiological effects that extend far beyond satiety. The body responds differently when amino acids are introduced before sugars and fats. The presence of protein triggers the release of digestive hormones, such as cholecystokinin and peptide Y, which send signals to the brain that food is entering the system and that the appetite can begin to subside. This early signaling prepares the body to handle the rest of the meal in a more regulated way. When a meal begins with protein, the pancreas is primed to release insulin in a controlled manner rather than a surge. This reduces the abrupt rise in blood glucose that occurs when carbohydrates are consumed first. Stable blood glucose means fewer energy crashes, less fatigue, and a reduced likelihood of post-meal cravings. Over time, this pattern improves insulin sensitivity, one of the key markers of metabolic health. In contrast, when the first bites of a meal consist of bread, rice, or sweets, insulin spikes rapidly, forcing the body to store excess glucose as fat while simultaneously suppressing fat burning. This is one reason why even a calorie-matched meal can have very different effects on body composition and hunger, depending on the order in which its components are eaten. Eating protein first also enhances nutrient partitioning, the way the body decides whether to use incoming calories for immediate energy, storage, or tissue repair. Protein ingestion increases thermogenesis, meaning that a portion of its calories is burned off during digestion. This higher metabolic cost not only boosts energy expenditure, but also ensures that subsequent carbohydrates are more likely to be used efficiently rather than stored. The amino acids released from protein act as signaling molecules that activate pathways related to muscle repair, immune function, and neurotransmitter production. These biochemical signals inform the body that nutrients are available for growth and repair, shifting metabolism into a more anabolic state that supports lean tissue preservation. The sequence of eating also has psychological effects. Starting a meal with protein changes the sensory experience of eating. Protein-rich foods tend to require more chewing and take longer to digest, sending mechanical and hormonal feedback to the brain that slows eating pace and promotes fullness. This naturally leads to reduced calorie intake without conscious restriction. It also prevents the sharp dopamine surge caused by eating refined carbohydrates first, which can drive compulsive eating behavior. Over time, people who consistently start their meals with protein often find it easier to manage portion sizes and resist cravings, even when presented with high-calorie foods. In addition, prioritizing protein first can significantly benefit those dealing with insulin resistance, prediabetes, or metabolic syndrome. Research has shown that consuming protein before carbohydrates can lower postprandial blood glucose levels by as much as 30 to 40%. This effect is mediated by the slowing of gastric emptying and the pre-activation of insulin and incretin hormones, which smooth out glucose absorption. The result is a more gradual and sustained energy release that keeps the body in balance. Even individuals who do not have diagnosed metabolic issues can experience more stable mood and energy throughout the day by structuring their meals this way. From a practical standpoint, the concept of eating protein first can be applied easily. For breakfast, this might mean eating eggs or Greek yogurt before oatmeal or fruit. For lunch and dinner, it could mean starting with a piece of chicken, fish, tofu, or a protein shake before touching the rice, pasta, or bread. Even a few bites of protein before consuming the rest of the meal can create measurable improvements in glucose and insulin response. The body's enzymatic and hormonal machinery responds rapidly, so consistency in this pattern compounds its benefits over time. When protein is prioritized before fats, it still provides a regulatory advantage. Although fats do not raise blood glucose the way carbohydrates do, they can delay digestion and increase calorie density. Starting a meal with protein ensures that the body's immediate focus is on building and repairing tissue before storing or burning fat for energy. It also encourages a balance between satiety and sustained energy, as the protein signals fullness while fats provide a slow, steady energy release. The synergy between protein and fat works best when protein takes the lead, as it prevents overeating by satisfying hunger more effectively and earlier in the meal. This order of eating also influences how the liver and muscles process nutrients. When amino acids enter the bloodstream first, they support liver detoxification and enzyme synthesis before the influx of glucose arrives. The liver then handles carbohydrates more efficiently, converting them into glycogen for storage rather than fat. Muscles, already primed by amino acids, become more receptive to insulin, allowing glucose to enter cells and be used for immediate energy rather than being stored in adipose tissue. This integrated metabolic response supports both short-term energy stability and long-term body composition improvements. Over the course of a day, repeatedly prioritizing protein first can lead to more consistent energy levels, fewer cravings, and improved nutrient utilization. This approach does not require strict calorie restriction or complicated meal planning. It simply aligns eating behavior with the body's natural metabolic priorities. The body is designed to repair and sustain itself first, not to manage excess sugar spikes or fat storage. By consuming protein before carbs or fat, you allow metabolism to follow its most efficient and health-promoting pathway, maintaining hormonal balance, supporting muscle preservation, and promoting steady energy throughout the day. Muscle preservation drives longevity because muscle tissue is not only the foundation of physical strength, but also a critical regulator of metabolic health, hormonal balance, and disease resistance. The amount and quality of muscle a person maintains directly influence how well they age, how efficiently they process nutrients, and how resilient they are to illness. Most people think of muscle purely in terms of fitness or appearance, But biologically, it functions as an endocrine organ, continuously communicating with the rest of the body through signaling molecules called myokines. These myokines affect inflammation, immunity, and even brain function. When muscle mass declines, these protective signals weaken, leaving the body vulnerable to metabolic disorders, frailty, and accelerated aging. As people age, they experience a natural decline in muscle known as sarcopenia, typically starting in the 30 seconds and progressing faster after the age of 50. This loss is not merely a cosmetic issue. It represents a fundamental decline in the body's capacity to regulate blood sugar, maintain mobility, and recover from illness or injury. Muscle tissue is the largest reservoir for glucose disposal. When muscle mass decreases, blood sugar regulation deteriorates, insulin resistance increases, and the risk of type 2 diabetes and cardiovascular disease rises. Preserving muscle, therefore, is one of the most effective strategies for maintaining metabolic health and preventing chronic disease. Protein intake and strength training are two of the most important factors that determine how well muscle is preserved over a lifetime. Adequate protein provides the amino acids necessary for muscle protein synthesis, while resistance exercise provides the mechanical stimulus that tells the body to maintain and grow muscle fibers. The synergy between nutrition and movement is what keeps the muscle machinery active. Without sufficient protein or stimulus, the body shifts into a catabolic state where it begins to break down muscle tissue for energy, especially during periods of stress, fasting, or illness. Once this process begins, it accelerates the decline in strength, energy, and overall function. The preservation of muscle also plays a central role in hormonal balance. Muscle tissue is highly responsive to anabolic hormones like testosterone, growth hormone, and insulin-like growth factor 1. These hormones decline with age, but maintaining active muscle can help sustain their levels and sensitivity. Conversely, when muscle mass decreases, hormonal signaling weakens, creating a feedback loop that accelerates aging. This decline is often accompanied by increased fat accumulation, particularly visceral fat, which produces inflammatory cytokines that further damage metabolic and hormonal function. Preserving muscle interrupts this destructive cycle, keeping inflammation lower and metabolism more efficient. Another reason muscle preservation drives longevity is its direct impact on mitochondrial health. Mitochondria, the powerhouses of the cell, are abundant in muscle tissue. They generate energy in the form of ATP, which fuels every cellular process in the body. When muscle is active and maintained through protein intake and exercise, mitochondria remain healthy, abundant, and efficient. This translates to better energy production, less oxidative stress, and slower cellular aging. In contrast, loss of muscle leads to mitochondrial dysfunction, fatigue, and accelerated biological aging. Maintaining muscle, therefore, is one of the most effective ways to preserve cellular vitality. Muscle also acts as a protective organ during illness or physical stress. In times of infection, injury, or surgery, the body relies on amino acids from muscle to produce immune cells, repair tissue, and synthesize enzymes and hormones. Individuals with low muscle mass recover more slowly, experience more complications, and have higher mortality rates in medical settings. In older adults, muscle loss is one of the strongest predictors of frailty, disability, and early death. The ability to rise from a chair, climb stairs, or walk without assistance depends on muscle strength, which in turn depends on consistent protein intake and resistance activity. These are not just lifestyle choices, they are survival strategies. Maintaining muscle also influences brain health. Active muscle releases myokines such as irisin and brain-derived neurotrophic factor, which support neuroplasticity, memory, and mood regulation. Studies show that individuals with higher muscle mass and greater physical strength have a lower risk of cognitive decline and depression. The brain and muscle communicate in both directions. As the body strengthens, the mind becomes sharper, and more resilient to stress. This connection highlights that muscle preservation is not limited to physical longevity, but extends to cognitive and emotional well-being as well. From a nutritional perspective, preserving muscle requires not just enough total protein, but also the right distribution throughout the day. The body can only utilize a limited amount of protein at one time for muscle synthesis, which means that spacing protein intake across meals optimizes results. Combining this with resistance training amplifies the anabolic response. Even modest increases in protein intake, especially for older adults, can significantly reduce the rate of muscle loss. Fasting or restrictive diets that lack adequate protein can accelerate muscle breakdown, leading to weakness and metabolic decline, even if they produce temporary fat loss. In a broader context, muscle preservation represents the body's capacity to adapt, repair, and thrive under stress. It reflects a metabolic environment where nutrients are used efficiently, inflammation is controlled, and the balance between growth and breakdown is maintained. Individuals who prioritize muscle through proper protein nutrition and resistance exercise not only look and feel younger, but also maintain the physiological resilience necessary for long life. In essence, the strength of the muscles mirrors the strength of the metabolism. The strength of the metabolism dictates how well and how long the body can sustain health. The thermic effect of protein boosts metabolism because the process of digesting, absorbing, and metabolizing protein requires more energy than any other macronutrient. When protein is consumed, the body must break down its complex amino acid chains, transport them into cells, and convert them into usable compounds for tissue repair, enzyme production, and hormone synthesis. Each of these steps consumes energy, meaning that a portion of the calories from protein is automatically burned during digestion. This phenomenon is known as the thermic effect of food, or TEF, and it is highest for protein, moderate for carbohydrates, and lowest for fats. While carbohydrates and fats may only use about 5 to 10% of their calories for digestion, protein can demand up to 20 to 30%. This difference creates a powerful metabolic advantage for those who prioritize protein intake. When protein is a central part of the diet, the body's resting energy expenditure increases. Even when sitting still, the metabolic rate remains elevated because protein stimulates processes like muscle protein synthesis and mitochondrial activity. This means that over time, a diet richer in protein not only supports muscle growth, but also helps the body burn more calories around the clock. This is one of the key reasons why individuals who increase protein intake often experience fat loss without intentionally reducing calories. The energy cost of processing protein effectively raises the baseline metabolic rate, creating a subtle but consistent calorie deficit that supports weight management without hunger or fatigue. Protein's thermic effect is closely tied to the preservation of lean muscle mass. Muscles are metabolically active tissues that require energy even at rest. The more lean mass a person maintains, the higher their basal metabolic rate. Protein supports this by stimulating muscle protein synthesis while reducing muscle breakdown, especially during weight loss or periods of caloric restriction. When a diet is too low in protein, the body compensates by breaking down muscle for energy, which slows metabolism and makes future fat loss more difficult. By keeping muscle mass intact through adequate protein intake, the metabolic engine remains strong and efficient. This is why two individuals with similar body weight can have drastically different metabolic rates depending on how much muscle they carry and how much protein they consume. The thermic effect of protein also influences how the body handles other nutrients. When protein is present in a meal, it slows the absorption of glucose from carbohydrates, preventing large insulin spikes and reducing fat storage. This effect creates a more stable energy flow with fewer peaks and crashes. As a result, People who eat more protein tend to experience steady energy levels, fewer cravings, and greater adherence to their nutritional goals. The body becomes more efficient at oxidizing fat for energy while preserving glycogen for when it's truly needed, such as during physical activity or stress. Beyond metabolism and energy balance, the thermic effect of protein has important implications for appetite control. High-protein meals increase the release of satiety hormones such as peptide Y and GLP-1, while lowering levels of the hunger hormone ghrelin. These hormonal changes reduce overall food intake naturally, not through willpower but through physiology. The body interprets protein as a nutrient signal that sufficient nutrition has been received, leading to a spontaneous reduction in calorie consumption. This is why high-protein diets are often described as self-regulating. They naturally align appetite with energy needs. Another dimension of the thermic effect is its role in adaptive thermogenesis, the body's ability to adjust its metabolic rate in response to energy availability. During calorie restriction or fasting, the metabolism tends to slow down as the body conserves energy. However, when protein intake remains high, this metabolic slowdown is minimized. The body continues to expend energy to process and utilize amino acids, preventing the sharp drop in energy expenditure that often accompanies dieting. This makes weight maintenance more sustainable because the metabolism remains active even in a caloric deficit. The thermic effect also interacts with the nervous system, particularly the sympathetic branch responsible for activating energy expenditure. Protein consumption increases norepinephrine activity, a hormone and neurotransmitter that stimulates fat oxidation and heat production. This is part of why high-protein meals can make people feel warmer or slightly flushed after eating. It's the body literally generating heat as it burns energy to metabolize amino acids. This process, known as diet-induced thermogenesis, contributes to the overall calorie-burning effect of protein and further differentiates it from carbohydrates and fats. Protein quality also affects the magnitude of its thermic effect. Animal proteins such as eggs, chicken, and fish tend to have a slightly higher thermic effect because they are complete proteins containing all essential amino acids and are efficiently utilized by the body. Plant proteins also contribute to thermogenesis, though their effect may be slightly lower due to fiber content and differences in amino acid profiles. Nevertheless, the consistent inclusion of both sources can sustain a strong metabolic response, especially when distributed evenly throughout the day. The cumulative effect of these processes explains why individuals who increase their protein intake often report improved body composition, higher energy levels, and better control over hunger. The body's metabolism becomes more dynamic and responsive, continuously using energy to process nutrients, repair tissue, and maintain thermogenic activity. Unlike crash diets that slow metabolism, protein-rich approaches build a stronger, more resilient metabolic system that continues to burn energy efficiently even at rest. The thermic effect of protein demonstrates that not all calories are metabolically equal. A calorie from protein triggers an entirely different chain of physiological events than a calorie from sugar or oil. It demands more energy to process, supports lean mass, stabilizes hormones, and enhances fat oxidation. This creates a metabolic environment that favors vitality, endurance, and long-term weight stability. When protein consistently takes center stage in nutrition, the body learns to operate at a higher energetic level, efficiently converting food into fuel rather than storing it as fat, which keeps metabolism strong and resilient throughout life. Protein controls hunger hormones naturally because it influences the intricate communication between the digestive system, the brain, and the endocrine system that regulates appetite and satiety. When protein is consumed, it triggers a cascade of hormonal signals that tell the body it has received sufficient nutrition. These signals travel through both the bloodstream and the nervous system to reach the hypothalamus, the area of the brain that governs hunger and energy balance. The hormonal response to protein is distinct from that of carbohydrates and fats, which tend to create fluctuations in blood sugar and appetite. Protein, on the other hand, stabilizes these signals, leading to a steady sense of fullness and reduced cravings. This is one of the main reasons why diets higher in protein are so effective at reducing overall calorie intake without conscious effort. When you eat protein, one of the first hormones to respond is ghrelin, often called the hunger hormone. Ghrelin is produced in the stomach and signals the brain to stimulate appetite. After a protein-rich meal, ghrelin levels drop more significantly and remain suppressed for longer than they do after a meal high in carbohydrates or fat. This means that the drive to eat is naturally reduced even several hours after the meal. The body interprets this drop in ghrelin as a message that adequate nourishment has been received, allowing hunger to subside without feelings of deprivation. In contrast, meals that lack protein can leave ghrelin levels elevated, creating a continuous sensation of hunger that encourages overeating and snacking. At the same time, protein consumption increases the production of hormones that promote satiety, including peptide Y and glucagon-like peptide 1, GLP-1. Peptide Y is secreted by cells in the small intestine shortly after eating and sends signals to the brainstem to reduce food intake. GLP-1 not only enhances satiety but also slows gastric emptying, ensuring that food stays in the stomach longer, which prolongs the feeling of fullness. Both hormones work synergistically to reduce the desire for additional food after a protein-rich meal. They help align the body's internal sense of satisfaction with its actual energy needs, minimizing overeating. Protein also affects cholecystokinin, another powerful satiety hormone released by the small intestine in response to fat and protein. Cholecystokinin stimulates the digestion of protein and fat by prompting the release of digestive enzymes and bile. But it also acts as a signal to the brain to stop eating. This dual action makes it particularly effective at balancing appetite. When cholecystokinin is activated, the brain perceives the meal as complete and satisfying, leading to a natural cessation of hunger. Carbohydrate-heavy meals, especially those high in refined sugars, fail to activate this mechanism to the same extent, which explains why people often feel hungry soon after eating a sugary snack or a bowl of cereal. Another key aspect of protein's influence on hunger hormones lies in its ability to stabilize blood sugar levels. Large fluctuations in blood glucose can cause corresponding swings in insulin, which in turn affect hunger signals. When insulin rises sharply after a high carbohydrate meal, blood sugar drops soon after, causing hunger to rebound. Protein moderates this effect by slowing the absorption of glucose into the bloodstream, leading to a more gradual insulin response. Stable blood sugar means more consistent energy levels and fewer hunger-triggered mood swings. This is why protein-based breakfasts tend to keep people satisfied for longer periods compared to breakfasts based on refined grains or sugars. The brain's reward centers also respond differently to protein compared to other macronutrients. Carbohydrate-rich foods, especially those high in sugar, activate dopamine pathways in the brain, creating short bursts of pleasure that often lead to cycles of craving and overeating. Protein, however, provides a more balanced and sustained sense of satisfaction. It does not overstimulate the reward centers, but instead provides a steady state of well-being associated with stable energy and hormonal balance. Over time, this shift helps recalibrate the brain's relationship with food, reducing emotional and compulsive eating patterns. Protein's control over hunger hormones becomes even more crucial during weight loss or periods of calorie restriction. When the body is in an energy deficit, it naturally tries to compensate by increasing appetite and slowing metabolism. However, a higher protein intake blunts this response. Studies have shown that individuals who consume adequate protein during dieting experience less hunger and maintain lean muscle mass more effectively. The body perceives that it is still receiving sufficient nutrition, so it doesn't amplify hunger signals to the same extent. This makes it far easier to sustain a calorie deficit without the constant struggle against cravings. Age also plays a role in how hunger hormones respond to protein. As people get older, hormonal sensitivity often declines, and feelings of satiety may take longer to register. Including higher amounts of protein in each meal can compensate for this diminished sensitivity by providing a stronger hormonal signal to the brain. Older adults who increase their protein intake often report improved appetite control, better energy levels, and reduced evening snacking. These effects are especially valuable in preventing age-related weight gain and muscle loss. Beyond hormonal control, protein has mechanical and sensory effects that reinforce its impact on appetite. Protein-rich foods typically require more chewing and take longer to digest, creating a stronger feedback loop between the gut and the brain. This physical process contributes to the sense of satisfaction that accompanies a high-protein meal. The longer digestion time ensures that nutrients are absorbed steadily, which supports sustained energy and prolonged satiety. The overall effect of protein on hunger hormones represents one of the body's most efficient self-regulating systems. By influencing multiple pathways, ghrelin suppression, peptide YY and GLP-1 activation, cholecystokinin release, and insulin stabilization, protein aligns the body's internal chemistry with true energy needs. This allows appetite to be governed by physiology rather than habit or craving. When meals are centered around adequate protein, the hormonal environment shifts in favor of balance, making it easier to eat intuitively, maintain steady energy, and avoid the constant fluctuations in hunger that drive overeating and metabolic imbalance. Quality of protein determines metabolic health because not all proteins are created equal in their amino acid composition, digestibility, and biological value. The human body requires 20 amino acids to build and repair tissues, produce enzymes and hormones, and regulate countless metabolic functions. 9 of these amino acids are essential, meaning they must come from food because the body cannot synthesize them. The balance and availability of these essential amino acids determine how effectively protein supports metabolism, muscle maintenance, and cellular repair. When the quality of protein is high, the body efficiently uses it to build lean tissue and maintain a healthy metabolic rate. When protein quality is low or incomplete, the metabolic processes that depend on these amino acids become compromised, leading to muscle loss, slower energy production, and impaired recovery. Animal-based proteins such as eggs, fish, poultry, and dairy are often considered high quality because they contain all the essential amino acids in proportions that closely match human needs. These proteins have a high biological value and a high digestibility score, meaning the body can absorb and use most of the amino acids they provide. Plant-based proteins, on the other hand, vary widely in their amino acid profiles and digestibility. Many plant sources are limited in one or more essential amino acids such as lysine or methionine, which can limit muscle protein synthesis if not properly balanced with complementary sources. This does not mean that plant proteins are inferior, but it does mean that achieving optimal metabolic support from them requires careful planning and variety. Combining different plant sources, such as legumes with grains or seeds with beans, ensures that the amino acid profile becomes complete and more effective for sustaining muscle and metabolism. The digestibility of protein is another critical factor in determining its impact on metabolism. Some proteins are absorbed quickly, providing a rapid influx of amino acids that stimulate muscle protein synthesis, while others are absorbed more slowly, sustaining amino acid availability over time. For example, whey protein is rapidly digested and ideal for post-exercise recovery, while casein is digested slowly, providing a steady release of amino acids that supports muscle maintenance during fasting or sleep. This variation in digestion rates allows for strategic use of different protein types to support different metabolic goals. The ability to match the right protein type to the right context enhances overall nutrient utilization and metabolic efficiency. The quality of protein also affects the thermic effect of food and energy expenditure. High-quality proteins with balanced amino acid profiles and high digestibility create a stronger thermogenic response, meaning the body uses more energy to process and metabolize them. This not only contributes to a higher metabolic rate, but also enhances satiety and reduces cravings. When protein quality is poor or digestion is inefficient, this thermogenic advantage is diminished, and the body receives fewer metabolic benefits from the same amount of protein. Therefore, focusing on both the amount and the quality of protein amplifies its impact on metabolism and energy balance. Protein quality has a profound influence on hormonal regulation as well. Amino acids act as precursors for important hormones and neurotransmitters, including insulin, glucagon, dopamine, and serotonin. A steady supply of high-quality amino acids supports balanced hormone production, stable mood, and improved stress resilience. When protein quality is lacking, hormone synthesis can become impaired, leading to disrupted appetite signals, mood swings, and poor glucose regulation. For instance, tryptophan, an essential amino acid found in higher quantities in complete proteins, is the precursor for serotonin, which helps regulate mood and appetite. Without adequate levels of tryptophan, serotonin production declines, increasing the likelihood of cravings and emotional eating. High-quality protein also supports liver function, detoxification, and immune health. The liver relies on amino acids like methionine and cysteine to produce glutathione, the body's most powerful antioxidant and detoxifying agent. Without enough of these amino acids, the body's ability to neutralize toxins and free radicals decreases, contributing to oxidative stress and metabolic dysfunction. Similarly, the immune system depends heavily on amino acids such as glutamine and arginine to produce immune cells and antibodies. Consistent intake of high-quality protein keeps these systems functioning optimally, ensuring that energy and nutrients are directed toward repair and protection rather than inflammation and damage control. Protein quality also affects how the body ages. As people get older, anabolic resistance, the reduced ability to build muscle from protein, becomes more pronounced. Consuming high-quality protein rich in leucine, one of the key amino acids that stimulate muscle protein synthesis, helps counteract this decline. Leucine acts as a molecular trigger for the mTOR pathway, the mechanism that signals muscle growth and repair. Proteins rich in leucine, such as whey, eggs, and lean meats, are particularly effective at maintaining muscle mass and metabolic rate in older adults. Without enough high-quality protein, muscle loss accelerates, leading to reduced strength, slower metabolism, and increased risk of metabolic diseases. The quality of protein also interacts with gut health, which in turn influences metabolism. Easily digestible proteins minimize the load on the digestive system and reduce the production of toxic byproducts from undigested food. Some low-quality or overly processed proteins can irritate the gut lining, alter microbiome balance, and trigger inflammation. In contrast, high-quality proteins, particularly when paired with fiber-rich plant foods, support a healthy gut microbiota that aids digestion, nutrient absorption, and immune regulation. A balanced gut environment enhances the metabolic benefits of protein, creating a positive feedback loop that sustains overall health. The source and processing of protein further influence its quality. Minimally processed whole food proteins retain more nutrients, enzymes, and natural cofactors that enhance absorption and utilization. Overly processed protein products, particularly those with added sugars, artificial sweeteners, or poor quality fats, may provide amino acids but lack the synergistic nutrients that support metabolism. Choosing clean, natural protein sources allows the body to process them more efficiently and reduces the toxic burden that can interfere with metabolic function. Ultimately, metabolic health thrives not just on how much protein is consumed, but on how well that protein meets the body's biological needs. High-quality protein fuels every system that keeps metabolism strong. It builds and maintains muscle, stabilizes blood sugar, supports hormone balance, powers detoxification, and strengthens the immune system. When protein quality is prioritized, the body runs more efficiently, energy levels remain stable, and the natural processes of repair and renewal continue to operate at their highest potential.